So today we're gonna be doing another PicoCTF challenge, and the challenge we're gonna be doing today is gonna be called Agua Valley. So with this challenge, the only hint that they give us is ever heard of format string attacks, which was basically the point of the challenge. So how do we do this, and how do we solve this challenge? So the thing with this challenge that makes it a bit different from the rest is that if we go to our downloads folder, now we have everything downloaded, and I have a solve script, but I guess I'll just redo it from scratch. So the difference between this challenge and the rest is that we had to use a format string attack. So we'll do from pwn import all. And since it's a format string attack, we just run it and see. We get 1, 2, 3. We get it printed out back. So what we want to be able to do is probably do a format string attack, but the one that I did that occasionally worked for this challenge was simply doing something like this, which was this. So it's gonna be %1 $P, and then we get I guess the P value, which is a pointer, but the very first one. So what do we want to do with this? So we want to be able to make a list right here. So we'll just ask Bing AI to make a list. Make a list of separated by and going up in numerical value up to 30. Like this. Add the other parts. Copy this. Separated by separated by. Looks like there might be a request. 30 of these. Oh my god, it's not reading it. So let's just refresh this. Make 30 of these, please. To be listed 30 times. It's basically my request. Phrases. Okay, then now change want to be going up to 30. P. Finally. So we got it. Took us a while. So let's just do this. And we see a bunch of stuff being printed out. But I guess a better way to look at it is through. Oh, it's because it. Oh, okay. Oh, it's getting annoying. Yeah, so make a list of up to 30. Separated by replace the one with numbers going up to 30. Oh no, this one. No, it didn't read it correctly. It's not reading it correctly. It's just pretty weird. Off the ones. No, it's not reading it correctly. I'm getting pissed off. So we have to do this manually, which sucks, but it is what it is. So we do something like this. One, and then separated. To $P, percentage 3, $P, and we get, like, I guess 3 specific values, but the one that we want to look for or do is basically $P. We want to be able to do this all the way up to 30, and that's what I was trying to do. So let's see if we can follow this pattern. This is why we can't trust AI yet. Go up to 30. So now we got it. I guess it just needed an example and then do this, but can't really do nothing with this because we don't understand. But it's leaking memory addresses. But if we go on GDB, we'll just exit out GDB Valley. We get GDB Valley, and now we want to do break star main, and then run, continue, then do that, then you type exit. You get a bunch of stuff, but the thing that we want to focus on is that some of the values got leaked, and the ones that got leaked was 555413, which is located in 555413, and it wasn't there. So we'll just do something like this as main, and just put more breakpoints this as main, and then break star main plus 18 or continue, and then we just put our that, and then exit. Okay, now we see that we basically leak 555413, which is the return address, and we see it right here. So we know we know where this is located now. But the value that also gets leaked is this value right here, 07FFFD3. So if we look closely at this and look up where this is at in the stack, so we'll just do this as this as no functions contains in the specific address. But if we go like 10 1 8 8, okay, we see no function addresses in this space. But if we do something like this as rs teleconnect and we can just look it up on itself, teleconnect Jeff telescope. So telescope is a way of basically dereferencing addresses in GDB. So we'll just use telescope. And what's telescope this? Just to see what we have. It should print out addresses, and we do see that here. Our instruction pointer is currently pointing at the return address, which makes sense because it's returning. We are basically done with the program. But now if we put one of these addresses, which is this one right here, we probably won't get nothing. We do. So this is basically where the stack and base pointer is pointing at, which is where our RIP value is instruction pointer, which is right there. And our stack pointer and base pointer are right there. But it's not pointing at the values we want it to point. So what if we go one space back? We go 8 spaces back, because that's how most of these are separated by 8s. So we go like this, minus 8. We see that basically that points exactly to the exact same thing. There's 2 references to it. There's 2 memory addresses, and we're going to be using these 2 memory addresses locate for the return address. So let's start building up our solve script. So our solve script is probably going to be like this. Oh, nano solve. Okay, downloads. My bad, I'm just tired. I've been reading so much about this. Nano solve.py. So pwn import all. So we're off to a good start. So what we want to be able to do is run process, and then process we want to be able to put our values, which is valley, and our value is valley, and then we just do dot slash, and then we're gonna do equals p. Now this is basically gonna run our process. Now what we want to be able to do is p send line our payload that we initially put, which is percentage 20 $sign p, and then percentage 21 $sign p. So, okay, now we have both of these, and then p dot receive into, because we're receiving something back. We want to receive it into, let's go with distance. Now what we could do now is basically get whatever gets leaked, and then we'll do equals p dot receive into receive line, basically receive line, and what we're gonna receive is basically, and we're gonna strip it first we're gonna receive it, strip it, and decode it, so we go play around with it. But what we're gonna be receiving on our end is basically these values, but separated like that. So we want to get these 2 values right around here, and just separate them in 2 different hex values, which we're gonna separate it by the little line that we made here. So we're gonna do something like leaks equals leaks dot split. I'm gonna split it in the middle, and now leaks has 2 values, and what we want to be able to do from here is play around with them. So we're gonna have first the stack address, which is the very first one is basically gonna be the stack address of, we're gonna grab the first one, which will be this one, and this is basically the stack, and the stack I'm assuming is only read access, so it's basically gonna be leaks, and then the first one 0 16 turn it to a hex, to an integer value, and then we're gonna do minus 8, so because we want to be able to point at this value right here, main, no, right here, yeah, because you see right here FDA 8 minus 8 is basically this, and then we could point to this value right here, the return value. That's why we do that. So this is basically what the return address, but in the stack level. Now we got the second leaks, which points to it. So we'll do int leaks 1, and then we're gonna turn it to 16, and that should be it for that one. Now what we want to do from here is do gdb leak. So our gdb leak is basically our value, this one right here, which is what we just got from gdb, because gdb is able to give us this value. So we want to get these 2 separate values right here, so I just copy this gdb leak right there, and then we want to be able to get the flag function, because that's basically going to print out our flag. So GDB flag is basically just this as print underscore flag, which is basically this value right here. And then we just take off that. Now, what we want to be able to do next is basically get the real flag, which is basically the real flag function, which is equals to our GDB flag, GDB underscore flag, minus our GDB leak, which was what we got it from leaking GDB. And then we're gonna add it plus the leak address, because the leak address might always be different, but if we get the difference between going from the flag and leak, it should be equal to the same thing. So it's gonna be to our leak address. Yeah, it should be equal to this leak address. Yeah, leaks. Oh, but this is leaks. We could probably just change this to leaks AD, our leak address. Return. Now we got that. Now what we want to be able to do is basically find the offset. So how do we find the offset? So how I found the offset was to basically go back right here, find the offset, go back to our payload. We have to get all these values at the beginning, copy them, and just like decode them. So this one, for example, we'll just decode this one, and then hex to string, and then see, look right here, this is where our thing starts to leak. So that's when we know our offset is that. If we're able to see our own payload and this is at the beginning, that means that's where this offset is at. So we see that this is 1 2 3 4 5 6 1 2 3 4 5 6. So it'll be this one, our offset 6. Now from here, what we could do is basically do payload is equal to FMT-STR, which is a payload used by Pwn tools to automate this, to be able to automate it. So we'll just do offset, and it's gonna figure out the offset for us. And then from here, we just manually put our stack address. So stack address, and then we're gonna put our real address. So, or real flag, I guess, real flag. So what we're gonna do is basically point real stack address, which is this return address, is gonna point to the real flag, and basically gonna execute real flag and print out the flag. And then we're gonna do right size, which is basically gonna make our payload short. The only reason is because if you look at the source code of the code, cd downloads, we see that valley.c, we're only giving 100 bytes, so we had to make this a bit short. And then if you guys want to see the size of the payload, I could do probably like print len of the payload, and then we could just do p send line and then payload. Now we could run this and see what happens. Python 3 solve.py. Receive nano. Oh, right there. Strip. FMT-STR underscore payload. probably do something like this. Oh, maybe because it's not, we're not doing this. So we'll do context dot binary. This is gonna set everything up for us. Equals dot slash value. It might be because it might be messing up our thing. So I'll do this. Python 3 and C. And now I ran it. Python 3 starting bytes x is now bytes. Oh, 64. So you see. And then we'll just do B. Stop that value. But it didn't, I guess. Oh, we'll probably do p.interactive. P.interactive right here. And we got something. Yeah, we set our payload. We got send line. We send as bytes. Receive into you heard in a distance. Strip decode. Leak split by that. Receive split 0.16 minus 8.16. We got both GDBs. And then we have real flag is going to be GDB flag minus GDB leak plus leak's address. Offset is 6 payload. Real flag and then stack address. And then p.send line and p.interactive. p.receive all. So Python. I think because it's breaking. Receive until distance. Let's see. You heard in the distance. See that? And then we just take out receive all right here. Control K. That was basically it for this challenge. Let's see. You heard in the distance. Okay then. Oh, GDB flag. Hopefully we GDB flag, GDB leak. GDB real flag is gonna be GDB flag minus GDB underscore leak plus leak address. Leak address and leak. $21 $P payload offset equals 6 payload equals FMT string payload offset stack address real flag. Then right side short. Then we send payload. Real flag. Split receive line strip leaks stack leaks address leak adds context out binary. Honestly, what could be making it wrong is maybe the ELF values. So probably be what E equals ELF, and then it's gonna be what? Dot valley dot / So now if you're on Python 3, solve.py, nano solve.py. So let's see what we could do right here. So Echo Valley. So we go Echo Valley PicoCTF. Because I feel like we got everything needed for this challenge. Let's see. Context.binary. Then we send line $. You heard the distance. Receive line strip decode leak split. 0.16 minus 8. 116 GDB leak. Oh, we need to exit off of it. I guess that's what I forgot. P dot send line, and then we just type what? P exit. And so it failed to open file because the directory is not there. So yeah. So you could probably go over what we did. So this is technically part of our format string attack. Format string attack. And then I guess we send them out. This basically decodes it from the values. Then we split it into 2 separate ones, and from here this leaks out the first value, which is the stack one, and this leaks out just an address. And this from we got it from GDB. This is similar to leak address, and then this is from the flag address, which is in the 555 format. So to get the real flag, we basically subtract the flag minus the leak, which is basically gonna get us the difference from to reach flag and leak, and then we just add up whatever we leaked in the address, because whatever we leak from the address could be different depending on the server host machine. And then we right here we find the offset by sending the payloads this right here we find the offset by sending the payloads that. And then from 6 we notice our payloads reaching it. That's why we got 6. And then the only reason we did this basically overwrites the stack address, the return address, to point to printing out the flag. And we used short since our buffer is only supposed to be 100 bytes. And then we just send the payload and exit out. And then we could change this to probably make it now work remotely on this right here. So let's launch instance and we'll just wait for this, and we could just change this to like this and do p equals remote, and then we just do remote to this specific value that we want, which is this one right here. And we just change the value right there, and then change it to the number that we want it to. which is this one. And now we should be able to see the flag, because it didn't work because it failed to open the flag. Reason being, if even though I do have a flag.txt, we check cat valley.c, we see that it has to be in the home valley flag.txt, and I'm currently on root download. So now if we run python 3 solve.py, we should get it, and it says congrats, here's your flag, PicoCTF flicker format fiasco. So now if we submit this, we should get a solve, and we do. So yeah, that's about it. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.